Hello friends, welcome to my lab. In this video, I will show you the basic operation of a relay and circuit breaker in a power system. If you love my video, please like it and don't forget to subscribe and share with your friends. Let's switch on. So let's draw the circuit diagram step by step. First of all, an outgoing line of any system voltage is taken from a bus bar. You can see a gap is placed in between the lines and we will put a switch in that position later. Now a CT, that means current transformer, is placed in that line. Basically a CT is used to perform two basic functions. Firstly, to step down the current and measure the line current at a certain ratio, and secondly, it works as a sensing element of a relay. In the figure, you can see the CT secondary terminals are connected with a relay coil. In between the relay coil, a soft iron plunger is placed, which is electrically isolated from the coil. Electrically isolated means no current will flow between the relay coil and that iron plunger. Now when the relay coil is energized, that means magnetized, then the iron plunger will be attracted, and when the relay coil will be de-energized, that means demagnetized, then the iron plunger will be released. Just like this. Now you can see a separate circuit is drawn just above the relay coil plunger. This circuit is called the trip circuit. The circuit contains a DC power supply from battery, a trip coil and two contacts. The contacts are placed just below the relay coil plunger. The trip circuit can be closed only by the relay coil plunger. Please remember that the trip circuit contacts are normally in open condition. Now you can see a separate plunger is placed between the trip coil, just like the relay coil plunger, and it can control the opening and closing of the main line contacts. Please remember that the trip coil contacts are in normally closed condition, and this is the part which is called the circuit breaker of the system, which helps to break the circuit in abnormal condition. Our diagram is done. Now let's discuss the operation of it. Assume that normal current is flowing through the line from the bus bar. As a result, a small amount of current is flowing through the CT and relay coil. Then the magnetizing power of the relay coil is very low to attract the relay coil plunger. This is the normal condition. Now let's assume a fault is occurred in the line. As a result, a huge amount of current will be flowed from the bus bar to the line. And according to the CT ratio, it will also carry a large amount of current from the CT to the relay coil. With the increase of the CT current, the magnetizing power of the relay is also increased and it attracts the plunger. The plunger will close the trip circuit and a current will be flowed through the trip coil. By flowing normal current through the trip coil, it gets energized. As a result, the trip coil plunger will be attracted, and finally the circuit is opened with the opening of the circuit breaker. As a result, the CT and relay coil will sense no current. Then the relay coil is de-energized and it releases the plunger. Then no current flows through the trip circuit and the trip coil is de-energized and the trip coil plunger is released, and the circuit breaker is in closed condition. Now you can see the main line is closed and normal current is flowing from the bus bar. From fault sensing by the CT to operation of the circuit breaker, it requires less than 1 second time for operation of the whole process. Did you notice that while making and breaking of the contacts of the circuit breaker, an arc was forming between the plunger and the contacts? Why this is occurring, please write in the comment box. Till then, stay tuned with us. Jai Hind, Jai Bharat.